Hey everybody, it's Miss Amy at the Grass Valley Library. Thank you so much for joining me for this episode of Random Acts of Science. Today we're going to be measuring wind speed. And the way that we're going to do that is by building a device called an anemometer. So the things that you're going to need, hopefully you've got all these things at home or can find them easily. You're going to need an empty water bottle or some other plastic container that has a small top on it like that. 3 wooden dowels. You're going to need 4 small paper cups and 1 larger paper cup. Actually, they probably could be the same size if they had to be. A little bit of electrical tape and a pair of scissors to cut that tape with. So we're going to build an instrument called an anemometer. It measures wind speed. This is called a cup anemometer. This is the same type of instrument that meteorologists and weather forecasters use in their work, but theirs is much more technically correct and complicated. This is a very simple way to do it, but it helps us understand the concepts behind measuring and calibrating and wind speed. So let's get started. This experiment is in 2 parts. The first part is building the mechanism, the anemometer. The second part is calibrating it. Calibration is the part where you're making sure that the machine is accurate, that the data that you're getting makes sense. So that's the second part. But first, let's build it. So you're going to take you're going to start with the biggest cup, and you're going to take one of your dowels, and you're going to thread it up through the bottom. So I poked a hole in the bottom already, but I poked it with the dowel. So if you force it in there, it should work. You're going to force it up through the bottom, so it looks like that. And then you're going to take the 2 other dowels, and you're going to insert them across the top of the cup at cross angles to each other. So I used a little hole punch to make a hole in the cup. If you don't have a hole punch, that's totally fine. You can use the tip of a pen or a pencil or anything sharp to get you started, and then you can insert the dowel that way. So I'm going to go ahead and insert the dowel through one side and out the other. So it's kind of looking like that at this point. My dowel has just points on it. Yours doesn't need to if you don't have that kind. And I'm going to take the second dowel and I'm going to insert it the other way. You'll notice that you need to make your holes not at the same height on the cup so that they cross over each other instead of running into one another. So it kind of looks like that. And the other part of putting this together is finding a way to tape it so that they're all working together. So that's where that electrical tape comes in. I've already cut myself a piece about this long, and what I found works the best, and this is kind of the picky part, is if you start about 1 inch below the top of the dowel and wrap it around once, and then your goal is to get it to go around all the other dowels at the same time. So it's a little tricky, but it totally can be done. Okay, it took me a minute, and I had to do a little bit of wiggling to get it all tight in there, but this is pretty much all together, and the goal is to get it so that it moves all together as one thing. So the next thing we're going to do is add the cups to the anemometer. So each of these little 4 cups that I've got, I've also poked some holes in here to make it faster when I show you how to do this, but again, you can make these holes with a pencil or anything else as you're going along. I've got 2 holes near the top of this cup, and they're both near the same side of the cup, and you'll see why here in a second. So what we're going to do is thread the top of that cup through the dowel, so it comes out the other side, and it's going to look something like that. So you can see where the one cup, it's hanging down below. You don't really want it on top, you want it down below like that. And then you're gonna do the same thing with the other 4 cups, and so they're all facing in the same direction. And that's gonna let it grab the wind from the same direction, and it's all gonna move together that way. So let's see here. Here's my second one. Okay, that also took me a minute, so don't despair if it takes a bunch of work on your part to get it looking like this. But now we've got all the cups going in the same direction, and we are ready to measure the wind. So once it's all together, my tape is still a little bit loose here. We're gonna stick it in our cup, and you should be able to just blow on these cups and have them start to rotate. So because it'll rotate freely in there, so let's try that. So that's how it works. It's pretty simple. So the last part of this is calibrating your anemometer. You're going to need an adult for this. you're going to need a vehicle, and you're going to need some sort of a timing device. That could be a stopwatch, or you could use the timer on a cell phone. That works really great as well. So you're going to wait for a very calm day, because if you have a wind speed already and you start moving in the car with your anemometer, those two things are going to be really hard to parse out, to separate. So if it's a calm day, then you're starting at 0, and you know that when this anemometer starts spinning, what's causing it to spin is the speed of the car. So you're going to get outside, you're going to have your adult get up to 10 miles an hour, and they're going to go straight ahead at 10 miles an hour for 30 seconds. So that means you're going to need a fairly straight street without a lot of traffic. And as you're going, you are going to put this out the window, and you're going to start counting how many times one cup revolves around that center dowel. A good thing to do is possibly decorate that cup with stickers or paint, or some way that you can easily track it with your eye, so you can start counting the revolutions or the rotations of that cup. So as you're going down the road, it's going to start spinning, you're going to start counting, and at the end of 30 seconds, you're going to record how many revolutions it made. It would be a great idea to do this more than once, so that you have a bigger data set, and you can make sure that you're pretty consistent with your answer. So let's say you counted 20 revolutions in the 30 seconds that car was going 10 miles an hour. This is starting to sound like a math problem, isn't it? So that means that the wind speed, you know that wind speed is 10 miles an hour because you created that speed, right? So that's what you can tell if you're counting for 30 seconds and you're finding that many revolutions. So if you set this in the yard and it starts spinning because there's a wind, and you count 20 revolutions in 30 seconds, you know that your wind speed is 10 miles an hour. What if you count 40 revolutions per minute? If it doubles, then what? Well, then your wind speed has doubled. It's that easy. So this is a great tool that you can try out and see how it works. It's also pretty fun just to understand how these anemometers work. They're much more technical. It'd be great if you can get to see one someday and see how they really work. But it's a pretty simple tool. So thank you for joining me for this episode of Random Acts of Science, and we hope to see you again soon.